Hi everyone, my name is James Spencer. I work for Murata Power Solutions and I am the European Technical Product Specialist. So get involved with a lot of field applications, technical support, overcoming power electronics challenges. I want to present to you today the future of power infrastructure for smart cities. It's something that we're very much focused on at Murata. We're always looking at new technology trends, and I want to showcase some of those to you today. So, welcome. I'll be your host. And without further ado, let's get into the presentation. So, just a question for everyone, really. I thought this would be quite fun. Really, obviously we're living in a very fast-paced world these days, and the populations are always rising. So, just for a question for everyone, what would be the world's predicted population in a city by 2050? Long way out to get your head around, but yeah, just have a guess. So I'll give you a couple of moments there just to have a think about that. And the answer is 70%. Wow. That really is amazing to me that more and more people are going to be congregating in cities. They're going to become more advanced, and this is going to place challenges on the infrastructure and importantly, the power infrastructure. So think about the global population rising, but within that, more people are locating themselves in cities. So really, smart cities, you may have heard of this term, Industry 4.0 basically relies on data. We are using data more than ever these days to change our lives. And how do we get it right for the future? So, what will this mean for the future of smart cities from a power perspective? And from any perspective, really. But they will grow. Of course, they will expand. The infrastructure will grow. They will become more power hungry. So, with expanding infrastructure, then power requirements will need to elevate to make sure that this is satisfied. They will become more densely populated, so people will be living closer together. So the infrastructure needs to support efficiency of people living closer together with transportation links, with housing, with farming, to maintain a sustainable environment and population. Existing city infrastructure will be strained if investments are not made. So if we don't invest in the future, obviously with expanding population and more people moving towards cities, then obviously that existing infrastructure will become strained if it's not upgraded and future-proofed. So just for everyone in the audience, I just want to take you through what is a smart city. Some people may have different definitions of what a smart city is, so I thought I'd just define the definition that I want to talk to you today about. A smart city is a technological modern urban area that uses different types of electronic methods and sensors to collect specific data. I mentioned to you about we are very much transforming the world based on data, and that's something that I'm a firm believer in. Make sure that we have the right data to do that and make the right decisions to future-proof correctly and ensure sustainability. So information gained from that data is used to manage assets, resources, services efficiently, and in return, that data is used to improve operations across the city. So how did we coin the term smart city? And this is something that you may have heard of before with the term smart. It can be put in front of many things, um, you know, smart cities or smart infrastructure. But really, what we mean by the term smart here is, you know, making decisions based on data. So, the image in the upper left-hand side there, as you see on the screen, very much signifies early industrial revolutions, mechanization. So really, automating processes mechanically and really and burning coal, but basic industry automation. But then we have an advent of the item in the middle there, which I'm sure everyone on the call will recognize as a lump of silicon. And with this, it was explosive in the fact that it transformed and created the digital age that we all live in today. And this is something that is going to accelerate even more exponentially in the future. We harnessed this, and now in the bottom right-hand corner, we are firmly reshaping how we mechanize and automate to improve our lives based on colossal amounts of data, and that's only going to increase. So I just want to present a slide to you that to illustrate that point that we have never lived in a more data-rich world. And of course, this is made possible by two facts there, 2 points that increases in computational power and storage have been dramatic over the last tens of years. And of course, as we see with all types of whether they're e-mobility solutions, rail transportation, robotics, an increase in sensors and the advancement of that sensor technology. And of course, I just wanted to illustrate that data is only useful if we use it, if we interpret it correctly, that it has constructs and a framework to add value in, and if it's computed and referenced sensibly, with some common sense. But of course, we can see that data is already a commodity. Of course, the internet really accelerated that with buying and selling data in the dot-com boom. But now we're seeing revolutionary apps like ChatGPT, which is the fastest growing web application in history. And there's a reason for that. And there's also a reason for why ChatGPT has come to fruition now, right? Because we have vast amounts of data, but we also have the ability to process that data efficiently and get it back to the user. But with that comes challenges, and also the protection of that data as it becomes more valuable. You think about companies with intrinsic IP that they don't want to get accidentally in the competitor's hands, then concepts like Web3, decentralization, blockchain, encrypted data, also for medical applications, whenever you've got data that needs to be secured, we need to be thinking about these concepts more and how we build the future infrastructure as data becomes more valuable. So how does exponentially more data enable smart cities? Well, if we're going back to the term and the definition there of how I originally highlighted, and there's a reason for why I took that definition, is that you can see in that definition, data's highlighted 3 times, and that's not a coincidence. It's very much driven by data. And decentralization on top of this ensures data integrity to ensure privacy, security, transparency that AI is currently missing. So we need to get this right in the future. What sort of things can we find in a smart city? Well, a variety of different things. And a lot of these things Murata Power Solutions supports with. So I want to take you through a few applications in the next following slides. But just to get you familiar with what types of applications we can find in smart cities and components. So you may have heard of Industry 4.0, new layer of manufacturing based on data, based on making process lines more efficient by analyzing and creating a model in some kind of digital rendering, digital twins you may have heard of, to really streamline processes. Smart government, so making decisions based on more data and feeding that into central government so that they can analyze and really look at what's required for the future. Mobility, Wi-Fi, smart digital citizens, so having actual identities and record keeping done in a controlled and smart way, which is efficient and secure. Open data feeds into that. Health, so we've briefly touched on medical applications in data security. Smart farming, agriculture. So as a rising population and as more of those people are predicted to move and congregate in cities, how do we feed the future populations with smarter ways of agriculture, producing higher yields and maybe using spaces differently? So you may have heard of concepts like vertical growth farming. Smart buildings, so building controls, access control, security, making sure that things are seamless with minimal effort, and yet the building looks after itself. Smart grid and energy utilities. So, really, from a power perspective, with all of this new infrastructure, how is it powered and how is it done efficiently? And how do we not waste power in doing that? So, we want to really utilize and have a smart energy grid system which is fit for all. And then finally, smart transportation. So, whether it's by train, you know, taxi, you know, electrical vehicles. How is that done in a way where, as people move towards cities and they're more densely populated, how does that travel infrastructure change so that travel systems are kept safe for everyone to use? So I thought I'd just look at a few cities, and this happens to be my home capital, London, UK. And to an independent survey, Be Smart there, it scored quite highly. I'm actually quite surprised to see the higher end of the score out of 100 to say that it's the most future-proof city for smart cities. I think cities have got a long way to go, but it depends on how you measure, how much of that infrastructure has changed. And in this case, they're looking at 5G towers, EV charging stations, green infrastructure, and this is a comparison that is done across European cities. So it may be different for if you're in the US or in Asia. But I think 73 out of 100 suggests that we've not got far to go to realize a full smart city. I would say we've got further. The sky's the limit with this. Of course, with its large infrastructure and government involvement, things will not happen quickly. However, we need to get it right for the future generations. So what's different about a smart city? Well, cities are set to become more connected. We're already saying, we commonly say to ourselves that the world is a small place these days, and that's by aircraft technology, so aerospace technology, and also data, the internet, bringing everyone together. It's never been easier to travel in this world, and it's never been easier to communicate. And this will just become more. So, how will the power infrastructure adapt and support this, all feeding into smart cities? We need more renewable energy. We need vast amounts of power to to basically support the future infrastructure because we're becoming so much more data rich that it's exponential. So that power requirement needs to follow suit to ensure that we fully realize AI. So we fully realize advanced neural networks and get to that point where neural networks are as advanced as ourselves. Smarter grid infrastructure, EV charging that goes hand in hand. We need renewable ways. We need clean, zero carbon emission ways of transportation. We need better communications, so 5G, 6G, and beyond. And then we need the IoT devices. We need everything connected on a decentralized network that can look after itself, preventative maintenance, healthcare, sensing technology. It's come so far. However, the future holds infinite possibilities for how advanced sensors can be and the compactness, integration, and the number of sensors on different vehicle classes, whether that's a transportation like a train or in e-mobility with cars, taxis, or whether it's on a robot in some kind of factory, or whether it's out in the wild itself. You may have seen autonomous guided vehicles, autonomous mobile robots. So with smart city applications, I want to focus on showing you a few concepts. So what do Murata Power Solutions as a whole brand, and that encompasses the whole group, focused on today? So we very much support computing and AI data center applications. And we do this with a variety of product classes, but mainly in what we call front-end AC to DC power supplies, and then the intermediary bus converters, which are the DC to DC links in between. So you take that initial, say, three-phase in, you split phases. Our products will take that single phase, transform it from AC to DC, and give you 12 or 54 volts out, and then that is then your bus voltage, and then that's transformed to different levels of requirement down to, you know, the silicon 1 volt kind of levels, 3.3, 5 volt logic voltages. And this has a raft of different applications in computing. So whether it's networking, server, storage, data center, this is advancing. And what we're seeing is we're bringing new waves of product class to meet the modular common redundant power supply specification, MCRPS, with our D1U 74. So the D1U is the 1U height, which is 40 millimeters, and then 74 and millimeters in width, with different lengths going back. And we're bringing out our most power dense product, which is 3.2 kilowatts in that specification. It's actually meeting the MCRPS specification. So it's that outline, 3.2 kilowatts, specifically geared at these types of applications. And that encompasses edge computing. So moving the computing power, traditionally it was held centrally and the user had to request, go back to the central link and come back with the answer. Now computing, we're all walking around with mini computers in our pockets, and different applications are now demanding computing power to make real-time decisions with ultra low latency. And this will push a tidal wave of edge computing all around the world. We're used to seeing the US and Asia dominate with big data centers. Europe has some as well, but edge computing can really change that. And why do we need that? Well, things like smart farming, robotics, they need to make real-time adjustments where the vehicle is. And therefore, the computing power has to be local to get that ultra low latency, to get that computing done at the edge. So examples of edge computing, in hospital patient monitoring, remote monitoring of assets, where you're moving logistics on a local site. You think of the big giants of the world in the logistics, how many packages are being moved inside a facility, but then around the world. Smart grids, predictive maintenance. So you think you're on a robotic line, robot goes down. What about if it has the data to potentially diagnose or fix itself in the future? I mean, at least diagnose so someone can come, not have to do the diagnostics. That's the kind of value that more sensing technology can really add. It can start to do some of the human function and take the work out of it to increase efficiency, to lower cost. So the advantages of edge data center, faster response times. I've talked about low latency and making real-time decisions where the application is located. Better security. Edge computing, or actually moving computing power closer to the edge, it may be referred to as on-premming as well, actually taking some computing power from the cloud, bringing it on premises for better security. You own that hardware and where the data is stored. Reduce network congestion. You're not flooding the network with requests, you're managing them locally. I often liken it to our own neural networks. I think we can learn by crossing over a lot from physics and biology and physics and electronics to biology, because usually biology's done it better, right? If you put your hand into fire, which I don't advise, obviously, you don't think about taking your hand away. If you accidentally catch, something from a hot source of energy, you pull away instantly, and that's because it's a reflex reaction. It never goes to the brain. That's a low latency process. Higher reliability with offline and low latency operations. So everyone is looking for high reliability. It doesn't matter whether you're in the industrial world or in the aerospace world. Everyone wants good reliability, because with that becomes less downtime. Or in aerospace, obviously it's critical. Lower costs as less power is used for local computer power. So how we use power in the future, how we manage the efficiency, I think we'll look back, in the next 100 years to now and say we were so wasteful with power, right? I mentioned about smart farming, and there are several companies working on this type of technology where you can run your farm remotely. I mean, farmers are very busy, they're stretched, they often have to do laborious tasks continually all throughout the day. They're limited on time, they're limited on the daylight hours. And so if you can automate more of this, while the farmer is then freed to go off and explore other entrepreneurial avenues to be more profitable, then this looks really, really appealing. And you can see some of our technologies there in the Murata Calyx. From Murata Calyx, we've got the BCA and BCE series and then the HBC series. So on the left, you can see a BCE series, which is an IP rated encapsulated switch mode power, non-isolated DC to DC converter. Takes from 48 to 12 or 48 to 24. And it's perfect for battery applications. So when you've got two, a high side and a low battery, if you're then using a 12 volt and a 48 volt battery, you have some kind of bidirectional capability there with that converter because it's bidirectional, non-isolated, and that can be used in lots of e-mobility applications where you're looking to send energy between a low side battery and a high side drive battery, for example, to power auxiliary modules on your vehicle. We then have a complementary HBC series, which is similar principle. We target these DC to DC converters for auxiliary applications on specialist e-mobility vehicles. So farming is a great one, but there's several others. You think off-road ATVs, you know, small road sweepers that are fully electric, any specialized vehicle. You think about airports with ground infrastructure, how many small vehicles running around that we need to convert to being electric. And people are still understanding how to do that. With the HBC series, you can go with the high side to 400 and 800 volts, and then down to the low side of 12 and 24. And this is obviously isolated, higher voltage, dual active bridge design, and it's bidirectional because of that. So with those two great technologies, we can really, really have a massive impact on smart agriculture. And this demand, the segment is forecast to grow massively because, like I say, the attraction of automating a lot of this repetitive tasks will be inevitable in the future. Wanted to show you a concept of your vertical growth farming. So some of you may be familiar with vertical growth farming, some of you may not. So I'll briefly introduce the topic. This is the idea of growing agricultural crops indoors under lighting. You can see there's several racks and trays there. You may have some automation to automatically water or select those trays, an automated system, but then they are powered by LED lighting rigs, which then have to, in turn, be powered from the grid. You can see that two main concepts I've depicted there or highlighted, and we've found that people are using. There may be more. So if you're in this space, then you may know more than this. But solution one, you get your three-phase supply in, that goes to a three-phase PSU, and then that is boosted up to high voltage, and then that is split over several LED drivers. Solution two, that obviously solution one is oversolve, but you can be oversolve in this market if you put the necessary safety and isolation requirements in, and obviously have appropriate measures of isolation for if you need to work on these systems to ensure that it's safe. Solution two is undersolve. You can get your three-phase supply in. This goes into a transformer and then into a rectifier, comes out less than self, and then you can distribute that over your LED drivers. So two different solutions. There's pros and cons of each. Personally, I think high voltage distribution for less losses. And then you can use the boost converter to do proper power factor correction as well. So yeah, there's different ways of looking at it. If you're distributing lower voltage, then you've got higher current, so you potentially got some higher losses, but you're then under self. So really depends on what you appreciate in your system. But two main concepts there for vertical growth farming. I wanted to then take you through some building access and security controls. So we actually have products that go into these systems already, and this would be from our, we call it board mount power type series. So you can see two little 1/16 brick power converters there. And if you look on our website, we've got lots of these types of modules. We can either do them open frame, as we call this, you can see them there, or fully encapsulated. We've got products for not only industrial building controls, but we have board mount power products, DC to DC isolated converters for rail, radio frequency power amplifier applications, for a lot of industrial applications that go outside of smart building control, including signage, welding, any type of process automation, little ATV, UTV um, kind of vehicles. They may have these smaller converters on to transform power down to logic voltages, for example, and also on a robotics side. So the autonomous guided vehicle and autonomous mobile robots use these smaller DC to DC converters to convert from the drive battery for the auxiliary electronics, whether it's the control, whether it's sensing technologies, little modules around for the brains of the vehicle so that it's aware of its surroundings. But from building controls, these are great for enabling automated security to have a more sophisticated and better managed building. They also help with energy consumption. And there's different approaches for how you implement DC to DC converters, whether you go for distributed or centralized. But if you go centralized and then low dropout or regulators, that could be less efficient. If you went distributed with several of these DC to DC converters, the overall system efficiency would go up. And that's what we really need in the future. We need more power density and we need better system efficiencies. So our DC to DC power bricks lend themselves to efficiently converting power, and we have some of the leading efficiencies on the market to enable this. So I wanted to take you, now we've done in the close future what we have today, I wanted to take you through some smart city applications for the near future. So power technologies enabling smart cities in the near future for energy monitoring. I mentioned about smart grids and how we can utilize more data to monitor what the grid is doing and how we channel energy efficiently for pockets of the grid infrastructure that are needing it at higher peak times than others. And we can use data to do this. So one smart city technology that's already been introduced in some cities is energy monitoring, and it's really collecting that data. We can form that data connection. We have products that have PM bus and data connection, so you can get that data out of the power supply to see how much is it being loaded, what are the peak loadings, and really start to analyze that data. So feel free to get in touch with us if you want to understand more about energy monitoring from our power supplies. Future power technologies from an IoT integration application. So this is a concept that IoT, again, we've got products with CAN communication to relay several aspects about the module. This is something that we're looking at. We don't yet have the products, but we are looking at this for the future, and we'd be very interested to speak to anyone who is interested in having IoT functionality in power supplies, whether it's a battery status, load levels, temperature, humidity. I've done from some research some UPS systems that already have this to allow preemptive and predictive maintenance. So if you think about your power converter and other systems um, within your high level system, wouldn't it be great if you can have data relaying on these critical systems to say, okay, what's the health of this system? Has it got any faults? Has it reached its service point? Is it due for some maintenance? And also having the system diagnose itself and do some preemptive monitoring is so valuable for then the runtime of that vehicle. And certainly the critical components within that, if you've got more data on those, you know when they're likely to fail, or if they have failed, you know that what the fault is before a service engineer has to go out, spend some time diagnosing. Some of that's done for you. And again, if we can make the power elements of this smarter, we can have that data available to give us that insights. Power technologies for asset management. So I attended a huge conference looking at asset management and logistics that really focused on these smart warehouse solutions for autonomous guided vehicles and autonomous mobile robot applications. The hardware, very much, as I mentioned briefly before, DC to DC power bricks, these things usually using 48 or 24-volt batteries and then transforming down or converting down to lower voltages for the control systems, for the brains of the thing. And in these products, we could look to have IoT integration again, security services. You don't want these things being hacked into or sent out of control. And then again, predictive preventative maintenance. This is going to be a huge area in the future as technologies become smarter, as we get more sensors so that electronics can diagnose themselves. And then that leads into battery health monitoring because all of these vehicles at the moment have a battery, some kind of power source. And then really looking ahead into the far future, I am fascinated by robotics. It's one thing that got me so passionately into electronics, and that's not changed since a young age. So now I have the ability to explore this in my professional life. It's amazing. And I very much love this quote. I look forward to the day when every municipality employs a team of Boston Dynamics. I mean, in this case, it's Boston Dynamics or Tesla, but every, you know, manufacturer in robotics can have a robot employed to improve the quality of citizens' life in various tasks. So whether that's fix all the roads, build a school, deploy solar, and so on and so on. Medical robots, things to really improve our lives and make a real difference. I believe a lot of this technology is inevitable. It's just the crossover point of when we get there. And a lot of these technologies are a lot more advanced than people think. Unless you're researching, unless you're looking at the latest and greatest, how much publicity does some of this stuff get in the news? I know from watching the news in the UK, we don't get a lot to see of this type of technology. So, and these have power challenges, right? So it's not only the power architecture inside the robot. I mean, these things need to be lightweight, power dense, and they have an energy source, obviously, to utilize that energy source most efficiently. So the robot, depending on what type of robot it is, can perform its task when needed. If it's an autonomous mobile robot or autonomous guided vehicle, it depends on the high level thought of what that robot needs to do. Does it have the ability where it can perform its task and then go and sit on a charger? Some robots may have that or may not. So that all places different challenges on getting the power infrastructure inside the robotic vehicle correct, but then also the power infrastructure that goes around that and the data infrastructure that goes around that. I mentioned our solutions that we have currently for edge computing, and this is a application that's set to grow massively in the future for robots, basically, to manage the data. If the robots are making real-time decisions and they require ultra-low latency, they might require their own edge computing data center where the robots are working. So it's a fascinating concept and something that I'm really hoping to map out in the coming months and really understand the power architecture required for these types of humanoid, but other robot classes, and really to conduct a market research study on that, really understand where that's now and where it's going in the future. But be sure our products, our power products, will support these applications. And it's something that if you're interested in, please reach out to us and have the conversation. So again, looking at the far future, I mentioned a little bit, I touched briefly on blockchain technologies for enabling data security. So as data exponentially explodes in the future with more advanced sensing and more sensors on different vehicle, whether it's a robot, whatever the application is, going to have so much more data around us in the future. I mean, think in the past 100 years, the data that we have today, and it's just exponentially increasing. That puts a huge precedence on the power requirement, but also in the security of the data itself. And so, can we look at blockchain-based solutions for managing that? We must look as a business ahead for added value, and I'd employ, every business to have this mindset. Starting from left to right there, we have quality, performance, reliability, power density, efficiency, and price. Of course, you compete on all of those factors, but some we compete on more than others. We are not the cheapest manufacturer of power. People come to us because of our quality, because of our latest and greatest technologies. We are a forefront innovator in electronics, in power electronics. There's a reason for why we have the tagline innovator in electronics below Murata, as you can see there in the logo. And what can we really stand out on? We must have a quality product, we must have performance that the customer values, must have the right level of reliability, power density, we're always pushing, and efficiency, we're always pushing to reach theoretical maximums. So what other things can we differentiate ourselves on? So for Murata, we're what we call a layer one business. Layer one to us means our componentry. People will know us for capacitors, for example. Layer two is the power products. So there's over a variety of different product classes from AC to DC transformation, from things like our D1 U74 you can see in the picture there, power supplies, our DC to DC converters, and DC to DC, converters for e-mobility and the Calix products. So, obviously from componentry to layer one to more advanced assembly, power supply, for example, layer two. This is internal references of what we describe these products as. But layer three, what do we mean by layer three? Well, Murata as a business, layer three means added services. So on top of, a hardware product, it could be a software or service. Why? Because we realize that the world needs smarter decisions to enable the future infrastructure. We need to save cost on things like preventative and predictive maintenance for the actual time for engineers to diagnose. If the electronics can do it itself, then that will save cost and time. Integrated IoT for continuous monitoring of critical systems and system optimization services. These are all advanced concepts that we're looking at in the far future. Layered software solution. Why? Less downtime, less labor cost, increased efficiency. We have to look ahead. So if you're interested in any of these concepts, we'd love you to reach out to us and gain your thoughts on these. I know from my time, I used to work for a few years as a reliability engineer, everything fails with temperature and time, and businesses will place value on systems which save time and resources. So think of a typical example here. We have a power supply, we have a fault or failure condition, and then, if it's critical system where zero downtime is allowed, it's costing the business money, you need to get a service engineer to look at that as soon as possible. The service engineer then has to conduct diagnostics and fix or replace. This may then go to supply chain to get the correct parts to make the fix or reorder parts to change the system, redesign, etc. Then the service engineer has to go back and then they have to fix the system. With the future, with exponentially more data, things like predictive and preventative maintenance concepts, automated supply chains, robotic systems, IoT connectivity, and sensors, we can slim this down a little bit. And we can get to where the power supply system diagnoses itself, reaches out to supply chain, interfaces with supply chain via IoT, identifies the parts that have failed, and actually then orders them up for the service engineer to install. Even better, the power supply fixes and diagnoses itself. I realize that's quite difficult to get your head around, but I believe it is the future and where the technology is going, enabled by AI really and data. If we get AI right with exponentially more data and sensing technologies, it's inevitable. So just one last, I hope you've enjoyed the presentation and learned a lot about Murata, what we have today, what we're interested in terms of power technologies and where we're following future trends. I just want to leave you on a question that's what's for you to think about. So take this away with you and Feel free to get in touch if you'd like to discuss. But what one thing would you do to change to help enable smart cities in what you do? So whatever industry you're in, whether you're in medical, industrial, wherever you are, whatever role you're in, what's one thing you would do to help enable smart cities? And with that, I'd like to thank you very much for listening. It's been a pleasure to present to you today. You and yeah, feel free to reach out if you have any questions. Like I say, my name is James Spencer, and please contact Murata Power Solutions, and we'd be happy to help. Thank you very much. Have a good day.